So looking at the mean value theorem, the mean value theorem basically states that if there exists a secant line between 2 points and the curve is smooth and continuous, there must exist a tangent line that is parallel to the secant line somewhere between the A and B domain. Okay, so this is what it states. This is the mean value theorem, how it's stated algebraically. Okay, so this is the average slope between point A and point B, and f prime is the tangent slope. Okay, so that we're saying that there must be some point that exists between A and B where the tangent line is parallel to that secant line. Okay, so just like with the intermediate value theorem, there we have a condition that has to be satisfied first. Okay, and that condition is that it must be smooth and continuous, not just continuous. So IVT needs just continuity. The mean value theorem needs smoothness as well, not just continuity, but smoothness. Okay, and we can see that if we draw this secant line here, yeah, at some point there is a tangent line there. No matter how we draw that secant line, as long as it's smooth and continuous, okay, as long as it's smooth and continuous, there must exist at least one point where that tangent line is parallel to the secant line. Okay, so that is a mean value theorem. Okay, and there's some fairly simple theorem, but there's some very high sophisticated applications of this later. Okay, so how do we apply this? Okay, so let's take a look. So first of all, make sure we understand the difference between the instantaneous slope, the derivative, and the average slope. Okay, so this secant line represents average slope. That tangent line is our instantaneous slope, which comes from the derivative. Okay, so here's an application problem here where you're told you have a closed interval from -4 to +6, and notice that it's got a kink in the graph, so this is not smooth and continuous at that point. Okay, it's non-differentiable there. So we know that from 0 to 6 it is twice differentiable. This means that the derivative is smooth and continuous. So we're looking for an f prime of c that equals 1/3. So what interval can we apply this for? So if I draw this 1/3 slope, okay, I need a tangent line that will have this 1/3 slope. Okay, and I can see it probably happens, right about there. That's pretty much the only point. But for what interval can I apply this? So can I apply this issue through the whole interval from here to here? Okay, well, first of all, we can't, because in that interval it does not meet the criteria smooth and continuous. So we don't have the condition that we can use to apply the mean value theorem. So that's not possible. So we can apply this through this interval here. Okay? So between 0 and 6, it's smooth and continuous. So if we can find some interval that has a 1/3 slope, we can say that there must exist some point in between or within that interval that has a tangent slope equal to 1/3. Okay, and so if I take a look at this, the interval that I want to use then is going to be that between 1 and 6. Okay, because that interval there has an average slope of 1/3, and what that means then is, since it's smooth and continuous, there must exist some tangent point with a parallel slope. Okay, so to be able to ensure that mean value theorem applies, first of all, we need continuity, so we have that, okay, in this whole interval, and we need, secondly, the average slope to equal that 1/3, which is our derivative slope right here. Okay, so in the interval, between 3 and 6, okay, f is smooth and continuous, and I'm just going to say differentiable. Therefore, mean value theorem can be applied. Okay, so the average slope in the interval 3 to 6 is going to look like this. It's going to be 1 minus 0 over 6 minus 3, which is equal to 1/3. And so the average slope equals the instantaneous slope at some point C, where we know that C must exist between 3 and 6. So we know that that point C must exist between 3 and 6. Okay, and that's true because that point C is, if I were to estimate it, somewhere around there, it looks like about 4.5. That point C does exist. We can see it visually exist in there. Okay, but again, the mean value theorem doesn't really need we don't need to visually confirm it. As long as we have the conditions, we know that that must exist. Right now, we want to make sure we see it so that we really understand how mean value theorem works. Okay, so the question then says, can we apply mean value theorem to state that there exists some point C prime, or f prime of C, that equals 0.15? Well, where that 0.15 comes from is the average slope within that interval. Okay, so if I draw that in there, what's that point there? That's going to be negative 0.5. Okay, so my average slope in there is going to be 1.5 over 10. Okay, so then in the interval of -4, they asked for the interval -4 to 6. Okay, the average slope is equal to, that looks like to be 2 minus 0.5. So it's going to be 1 minus -0.5 over 6 minus -4, which gives me the 0.15. Okay, and we can say that, can we say that there must exist a point in here? Well, we see that there can exist, but can we apply mean value theorem here? No, we can't. Okay, so the function is not continuous, therefore we cannot apply mean value theorem. Okay, so again, this issue is that it's important that we meet the condition first before we can apply mean value theorem. If we can apply the condition like we did in the first part here, where we had the condition of smoothness and continuity, okay, we can say that there is some point C in that interval that we can apply the mean value theorem to.